Good evening. Today we are going to see the assignment number 11. Now in this we are in the following figure, three members AO, BO and CO are given. And we have to find distribution factor for OC member for this member. Now we have this will be move vertically and this angle between the member and support will remain same. So if it will go somewhere here, then this angle will be like this. And therefore angle required, this angle will be like this. And for this, we require moment that is EI by L. So if we have simply supported, we know it is 3 EI by L. And if it is fixed, we have 4 EI by L. So we have stiffness of OA, stiffness of OA is equal to EI by L. Then stiffness of OB, 3 EI by L, and stiffness of OC is equal to 4 EI by L. And therefore we will get total stiffness at O. Total stiffness at O, and that is equal to 8 EI by L. And we are interested to find distribution factor of OC. So we have distribution factor of OC equal to stiffness of OC divided by total stiffness at O. Total stiffness at O. And therefore we will get it as 4 EI upon L divided by 8 EI upon L, and we will get this value as 0.5. So we have option as B. Now we will switch over to the second problem in the figure. Suppose a moment of 2000 Newton is applied at O. What is the value of moment OC? So we have MOC equal to distribution factor of OC, distribution factor of OC multiplied by M. And distribution factor of OC is 0.5 into 2000, and that will give us value as 1000 kilonewton meter. Option we have A. Now we will go to third problem. So now again we have for OA EI by L. Now OB will not have any slope, it will directly go in this fashion. So we do not have slope for this. So we have 0. For OC we know 4 EI upon L, and for OD we know 3 EI upon L. And therefore we will get stiffness of OA EI by L, stiffness of OB 0, stiffness of OC 4 EI by L, and the stiffness of OD 3 EI by L, and total stiffness at O and that is 8 EI by L. And we are interested to find for OA, and therefore distribution factor of OA, distribution factor of OA, and that is equal to stiffness of OA stiffness of OA divided by total stiffness at O divided by total stiffness at O. And then we have this is equal to EI by L divided by 8 EI by L, and this will give us 1 by 8, which is equal to 0.125. So we have option is C. We will go for this. Now we have OA again EI by L. OB we have 4 EI by L, and OD we have again 4 EI by L. O rank we do not have stiffness, so we have stiffness of OA EI by L, stiffness of OB, stiffness of OB 4 EI by L. Then we do not have stiffness of OC, then we have stiffness of OD again 4 EI by L. So we have total stiffness at O, total stiffness at O, and that is equal to 9 EI by L. And we are interested to find distribution factor for OB, and therefore distribution factor for OB, distribution factor for OB, and that is equal to stiffness of OB divided by total stiffness at O divided by total stiffness at O. Now OB we have 4 EI by L, and total we have 9 EI by L, and from this we will get 4 by 9, and that is equal to 0.44, and we will get answer, that is option we have answer is 0.44, and option we have D. Then we have fifth problem. What is the absolute value of bending moment at B and C? So we have to find B and C. So now we will go stiffness of OA BA, and that is equal to 3 EI by L. And if we will put the value, we will get it as 3 EI by 6, and that is equal to 0.5 EI. Now if we will go for SBC, then we have 4 EI by L, and that is equal to 4 EI by 8, and that is equal to 0.5 EI. As we have same stiffness for both, therefore we will get distribution factor same as our stiffness is same. So distribution factor for for BA equal to BC equal to 0.5. Now we have fixed end moment, so we have MF AB minus, now we know WL square by 8, so I will not write formula, minus WL square by 12, and we have minus 48 kilonewton meter. Then we know we have MFBA 16 into 6 square by 12, and that will be 48 kilonewton meter. Then we have MFBC minus WL by 8, and that is minus 24, and MFCB we have 24 kilonewton meter. And now we will solve it by moment distribution method. and then we will have in this way. So if we will prepare the table, then we have this table at joint. So we have joint, then we have member, then we have fixed end moment. So we have A, then we have joint B, member AB at A. For B, we have two members, BA and BC, and then at C, we have CB. Now we have this as minus 48, this is 48, minus 24, and this is 24. Now support A, we have simple support which is end, so we have to release support A. So release A, and then release means we have to add opposite moment, and then we have to carry over to BA, which will be 24, and then from this we will get find total moment over here. So we will have total moment, and then we will get total moment over here, so that we will calculate, and we have this total moment, that is 24 here becomes 0. This will be 72 minus 24, and this will be 24. Then we have distribution factors already we have calculated, 0.5, 0.5, which will be our distribution factors. And now if we will distribute 72 minus 24, then it comes 48. So half. So we have distributed moment, and that is minus 24, and that will be minus 24. And then we have carryover on this side only, which will be minus 12. This is your carryover. And then we will get final moment over here. And that final moment we will get it as, this will be MAB will be 0. So this is final moment. This is 0. This will be 48. Then this will be minus 48. And this will be 12. And we are interested to find at B and C. So we have 48 and 12. So we have option, that is A option. So we have, these are the 5 problems from 11 assignment. So we will stop here, remaining we will solve in the next lecture. Thank you.